question here. A company had the following results for the 5 years on its portfolio. Okay, 2017, these are the returns. Okay, 2018, 2019, 2020, and 2021. In addition to the statistics provided above, inflation averaged 7% and interest rates are projected to average 12% for the next 3 years. Compute the standard deviation for the results. So here we are going to focus on the standard deviation of these historical results. These interest rates which are predicted in the future, it's a different set of results. You cannot work with historical and future results and put them together. No, we're only going to focus on the historical results to find the standard deviation. So this inflation and this 12% are not relevant. We are focusing only on our historical data here. Right? So you don't need to mix historical and future data. Okay. Yes. So the first thing, so the standard deviation, it's just telling us how risky this portfolio is. We're not talking about risk. We're just talking about how our returns, how far they deviate from our average return. Okay. You want your portfolio to have a low standard deviation, meaning the returns that you're getting should be near the average return. That's a more stable portfolio with a small standard deviation. But the bigger the standard deviation, it means your returns fluctuate very far from the average. So it's not stable. The portfolio is not stable. Okay. All right. So the first things first, we need in order to get the standard deviation. First, we need to get our average return, our mean return. Okay. So remember, the average or the mean. This formula we learned in first year statistics. Summation of x divided by n. In this case, our x are these returns here. Yes, these values here represent x. Okay. The n number of years: 1, 2, 3, 4, 5 years. Okay. Mhm. So we're going to add our returns. 11% plus 7% plus -6% plus 12% plus 4%. That gives us 28. And our mean return or average return, you're going to say we're going to say 28 divided by 5. Okay, oh, let me zoom in so that. Are you able to see clearly? Here, I've zoomed in. First, we're adding the returns. Yes, we add the returns first. 11 plus 7 plus -6 plus 12 plus 4, we get 28. And to get our average, the total returns divided by number of years, 5, 5.6%. So this is our average return. I added these values, 5 years. Yes. So our average return is 5.6%. Yes. So after that, we need to get our standard deviation. Okay. Our standard deviation is this. This is the formula for the standard deviation. Sigma equals the square root of the summations of each our deviations over n minus 1. Okay, madam, this formula is a formula for the standard deviation. This, which six? It's sigma. It's sigma. So our mean x bar is 5.6. Our returns, which are represented by x, okay. Our returns here, annual HPYs, will represent them as the x. Okay. Any questions? All right. Next, after I get the average return, you get the deviations now. How far each return is from the average? That's what the deviation is, madam. Okay. How far each return is from the average. Okay. Yes. So this x minus x bar, each of these returns, you are going to subtract it from the average. Okay. This average. X bar is the average. X is the individual return. Mhm. So, like this, for example, x, our this 11, how far is it from the mean of 5.6? Is 5.4 units away. Minus 11 minus 5. Mhm. The next one, this 7, how far is it from the average? 1.4 units. This negative 6, how far is it from the average? Negative 6 minus 5.6, negative 11.6 units. Okay, you're just saying how far each return is from the average. Okay. This return of 12, 6.4 units away from the average. This 4, 5.6 negative 1.6 units away from the average. The negative means it's to the left of the average. Think of the average. This 5.6 is in the middle here. The negative values are to the left. The positive values are to the right. These are what we call our deviations. How far each return is from the mean. Then the standard deviation is like the average distance our data points are from the mean. Okay, that's the, that's what it means. Well, that's what standard deviation is in actual sense. The average distance your data points are from the mean. Now, in the financial world, that translates to risk. All right. If your data points are further away from your mean, it means that investment or that portfolio is risky, meaning your returns fluctuate. So you might not get what if you'll be expecting your average, but you might get something way far from your average. Okay. You might make a bigger loss or you might make a bigger win. Okay. Yeah. So next you square the deviations now. Okay. Because in this table is representing this formula, madam. Okay. We're doing the we're doing here first we've done x minus x bar. Next, we are squaring this x minus x bar. Okay, our squared deviations. So each value we square. 5.4 squared, 1.4 squared, negative 11.6 squared, 6.4 squared, negative 1.6 squared. Okay. Yes. Any questions, madam? All right. Then next thing is we're going to, have you seen this sigma sign here? Yeah, we're going to add these squared deviations. 209.2. So we say here 209.2 over 5. N is 5. Minus, yeah. So 209.2 divided by 4. Let me put a 4 here. Yes. Which one was squared? Mm. Why? No, we're already squaring each of these. So 209.2 divided by 4, you get 52.3. And you say the square root of 52.3, 7.23. So 7.23. So this is a relatively small standard deviation. Okay. The bigger the number, the bigger the standard deviation. So 7.2 is kind of relatively small. It means on average, our data points are really not that far from our mean. They're relatively close to the mean. Okay, so it means on average, our returns should be around that 5.6 area. All right, they should cluster. They watch things. Yes, I'm going to put them on the document there. Mhm. Yes. So this has a small standard deviation, so it means it's a relatively stable portfolio. Okay, our returns are not very far from the average, because remember the average is a benchmark. It gives you a where you're standing. Okay, it gives you your position of what to expect. Okay, so this portfolio, our returns are not very far away from 5.6. Okay, yes, so it's a relatively stable portfolio.